Hello, welcome to 2.6 Algebraic Proof. We are going to begin actually solving proofs, and in a proof we need something that states that it's true. To state something is true, we can use theorems, axioms, postulates, things like that. So an algebraic proof is an argument that uses logic, definitions, properties, and theorems to show that a conclusion is true. An important part of writing a proof is giving justifications to show that every step is valid. Below are some of our algebraic justifications. These you have had every year, but I think you mostly forget them as soon as you've learned them. The addition property of equality states that if you have two equal things, you can add the same thing to both sides and it'll be true. So if A is equal to B, then A plus C is equal to B plus C. We just added C to both sides. If you understand this concept, the next three are going to be very similar. So the subtraction, if A is equal to B, then A minus C is equal to B minus C. Multiplication property, if A is equal to B, then AC, which we know is A times C, is equal to BC, which is B times C. The division property of equality, if A is equal to B and C is not equal to 0, then A divided by C is equal to B divided by C. It's important to say that C is not equal to 0 because we know that we can never divide by 0. So that's why this is on this one, but not the others. Now these other ones I do know that you've had, but once again, I'm sure a lot of you have forgotten them. The reflexive property is just A is equal to A. Sounds very obvious, but it does come in handy, especially next unit. The symmetric property of equality states that if A is equal to B, then B is equal to A. This is going to come in handy if a lot of times when you solve equations, if you end up with something like 5 is equal to X, a lot of you write X is equal to 5. So you switch the two sides. When we're actually proving something, you have to state the reason, and that's when the symmetric property will come in. Transitive property is if A is equal to B and B is equal to C, then A is equal to C. The substitution property of equality, if A equals B, then A may be replaced by B in any equation or expression. So then A may be replaced by B in any equation or expression. The difference between an equation and an expression is an equal sign. Distributive property you should have done last year. So if we have A times the quantity B plus C, we can distribute that A, so that would be AB plus AC. We distribute that A to everything inside. And combining like terms, if you have AB plus CB, you can take and add these two things, so you'll get A plus C quantity B. So if you have 2x plus 3x, it's 5x. So here we're going to start solving. So prove that if 4m minus 8 equals negative 12, then m equals negative 1. Write justifications for each step. This is what you're learning about now. Obviously, you know how to solve this. When we solve this, the first thing here that you would do to solve this is you would take and you would add 8 to each side, giving you 4m equals negative 4. Well, what did we do right here? We added something to both sides. So that's the addition property. We're going to put the steps off to the side. It's technically the addition property of equality, but you can just write addition property. And then from here, we would then take and we would divide both sides by 4, giving us m equals 1, negative 1. Well, what did we do? We divided, so we used the division property. and those are our justifications. So example 1 is a proof of a conditional statement. If 4m minus 8 equals negative 12, then m equals 1. Remember, a conditional, if p, then q. Notice that the column on the left is the step-by-step process that leads to the solution. The column on the right contains the reasons for each statement. So we call this a two-column proof. So a two-column proof in geometry contains statements and reasons organized in two columns, and we're going to do that again. So in geometry proofs, the reasons can be postulates, axioms, properties, or theorems. And theorems is Theorems. So the given statement is information provided, and it is accepted as true. And the statement that says prove is the statement or conjecture you're proving to be true. So here we're going to prove if negative 2x plus 14 is 10, then x equals 2, and justify each step. So the first step in all proofs is given. It's always written there, and your reason is given. That should be the easiest thing for you to fill out. There really should not be any thought about that. So then you ask yourself, well, what would I do to solve this? To solve this, you would distribute that negative 2 first. So you would do negative 2x plus 14, and you'd bring everything else down. Well, what did you do? You used the distributive property. Looking at this, the next thing you would do is you would simplify, or you would combine these terms. So, whoops, I should be using blue here. So we'd have a negative 2x plus 12 equals 8. And we combined like terms. Some places you will see simplify. So if you wrote simplify, I would accept that too. Now, I would not accept you combining these two steps and saying simplify. You can only do one type of thing per step. Then the next thing that you would do is you would subtract 12 from both sides, leaving you negative 2x equals negative 4. So what did we do here? We subtracted from both sides. So we use the subtraction property. And then finally, we're going to divide both sides by negative 2, leaving us with x equals 2. So we use the division property. Algebraic proofs just simply prove how you solve equations. These are going to be the kind that are going to come easiest to you at the beginning because you have been solving equations for so long. This is what I had said before, though. If we had ended up with x on the other side, if we had ended up doing all of this solving and got 2 equals x, then we would need to use the symmetric property to make the x on that side. You can't just flip things without saying the steps. And when we prove, we want the x on the left. So that is it for today. Thank you.